All right, welcome back. So this time we're going to go into regions and zones. Why does geography matter? But before we get started, hit the like button, subscribe, share with anyone you know taking the GCP machine learning exam. So understanding geographic infrastructure. Google Cloud's global infrastructure consists of regions and zones. These are physical locations housing data centers and compute resources. Understanding this geography matters for performance, availability, and compliance. Regions represent geographic locations around the world. So you have US Central 1 in Iowa, you have Europe West 4 in Netherlands, and you have Asia Southeast 1 in Singapore. Each region operates independently with its own power, cooling, and network infrastructure. Regions contain multiple zones, typically 3 or more, to provide fault tolerance. Then you have zones. These are isolated locations within regions. You have US Central 1A, US Central 1B, US Central 1C. Each zone consists of one or more discrete data centers with redundant power and networking. Zones within a region connect via low latency, high bandwidth links. All right. So why do regions matter? All right, here's one. Data residency and compliance. So regulations like GDPR require certain data to remain within specific geographic boundaries. So healthcare organizations might need PHI, or protected health information, to stay within US borders. Financial services might require data sovereignty, keeping customer data in country. When creating machine learning workloads, select regions that satisfy your compliance requirements. If your training data must remain in the EU, create Vertex AI datasets, training jobs, and storage buckets in EU regions like Europe West 1 or Europe West 4. Then you have latency, all right, and performance. So network latency between regions can reach 100 to 300 milliseconds. For ML workflows, co-locating resources in the same region dramatically improves performance. If your BigQuery dataset lives in US Central 1, run Vertex AI training jobs in US Central 1 to avoid cross-region data transfer delays. Real-time prediction endpoints serving user-facing applications should deploy near users. For a global application, deploy model endpoints in multiple regions. US Central 1 for North American users, Europe West 1 for European users, Asia Southeast 1 for Asian users. Cloud load balancing automatically routes requests to the nearest endpoint. Then you have high availability. So distributing resources across multiple zones with regions protects against zone failures. While rare, entire zones can experience outages due to power failures, network issues, or natural disasters. Multi-zone deployments ensure your ML services remain available even when one zone goes offline. All right, so how do you select those zones? Okay. When selecting these resources, you need to specify a region or a zone. You have regional resources, right? Like BigQuery datasets, cloud storage buckets with regional redundancy, or Vertex AI managed datasets. Automatically replicate across zones within the selected region. If one zone fails, resources remain accessible from surviving zones. Then you have zonal resources, okay? These will be virtual machines, persistent disks, some Vertex AI services. These exist in a specific zone. You must explicitly create resources in multiple zones for high availability. Then you have multi-regional resources. So think cloud storage buckets with multi-regional redundancy. You can replicate across multiple regions for maximum availability and geographic distribution. This is useful for serving model artifacts to globally distributed applications. So for practical choices, imagine building a fraud detection model for a global e-commerce platform. Your architecture might have training data, think like BigQuery datasets in US Central 1, where your data warehouse lives. Training jobs, right? You'd have Vertex AI custom training in US Central 1 to minimize data transfer. Then you have model storage. So your cloud storage bucket in US Central 1 would be there for training artifacts. And then you'd have prediction endpoints, one in US Central 1 for North America, Europe West 1 for European traffic, Asia Southeast 1 for Asian traffic, and a global load balancer. This would route predictions requests to the nearest regional endpoint. So this type of architecture would balance performance, meaning training co-located with data, predictions near users, availability, meaning multi-zone regional resources, and cost efficiency, which would avoid unnecessary cross-region transfers. So that'll be all for this one. But before we go, hit the like button, subscribe, and share with anyone you know taking the GCP Machine Learning Associate exam. Thank you. Have a good day.